Like given but it's the exact same wording, it's just different letters based on the letters that they gave in the picture. So they gave you triangle PQR, that is the original triangle. Oh, sorry, it's frozen there. Oh dear. Sorry, a lot happening. Okay, they gave you triangle PQR, and then guys, they will tell you that S is the midpoint of that side and T is the midpoint of that side. All right, they have to give you that information because you use that obviously to prove the whole thing. So like I said, it's fine if you didn't write that in, but maybe just add it in now. They're required to prove the same, guys. ST is parallel to QR. It's always that line from midpoint to midpoint. That one is parallel to the third side of the triangle. And then also that this line, ST, is half the length of QR. Those are the two statements that you're going to have to prove. So RTP, you are allowed to just write RTP. But guys, normally for this, they give you like almost like a fill in the blank kind of page, right? Like an answer sheet. So they'll give you the picture, you'll draw it on the diagram there, and you'll pull it in like online. That's usually how they ask it. Now for the construction, you had to construct that parallelogram there to the side. So I just wrote there, extend ST its own length to point U. I made that point U because I was just going with the alphabet. But you might have used a different letter there, that's fine. Then your proof just would look a little bit different. Obviously, you didn't use U. And then you need to draw in that palm. So you are drawing in PU, RU, and SU. SR. SR, yes. Okay, so you're extending it to point U and then you're drawing it to the other three sides. Yeah. What do you mean to the others? Did you draw to the other side? Yeah, that's right. Hmm. Yes.
So it says the
Mhm. That's fine. Yes. All right, so then guys, the proof just follows on from there. It's exactly the same as what we wrote down yesterday. It's just now using different points. You just need to be very careful that, or just make sure that your proof actually follows the point that we put in. So like I said earlier, if you didn't put in a point U, say you used what, a V, for example. Then wherever I've written U, you would have had to write V. Right? Does that make sense? So just double check that, or your reason must be there, yeah? That's fine. Yes, that's what Erin was asking about. Yeah, that's fine. Then your stuff will also be copied. Just see if you guys agree with that. If there's anything you want me to just explain again, or to just clarify, or maybe if there's a mistake there, I hope not. Yeah. Midpoint theorem on graphs. We're gonna have to calculate the midpoint of a line. Yeah, on the particular paper. We'll do that. I think it makes the like analytical job. That's another thing that I just actually mentioned yesterday. When you are naming your parallelograms, right? So I'm looking at my second line here and my fourth line. The order of your letters does not have to be exactly the same as mine, but what is important, I'm just going to go back up to mine quickly. So I wrote PSRU when I'm looking at this palm here. So I wrote PSRU. I also could have written PURS. I could have written SPUR. Or SRUP, you can basically start with any point and go in any direction, but the points, the order of your points has to be the order of the vertices, if that makes sense. So I can't write SURP, right? That won't be correct. If you're starting with S, you either have to go to the next vertex, which is P, or if you're going the other direction, U. No, sorry, R. I'm blind, I didn't see that. All right, or if you want to start with R, you can say RSPU or RUPS. Okay, does that make sense? Right? So the vertices, the way in which you order them in the name has to be the same as the order of the vertices in the actual parallelogram. Okay, so if you don't have the exact same name, that's fine. Just check that it does actually go around the one. Yeah. You asked me the exact same question yesterday. All right, are we fine, guys? Any other questions? You can ask me a little bit longer so you can see me. If you are done, you can start writing the next headings along Converse midpoint theorem. Converse midpoint theorem, 3 words.
It's under midpoint here.
So we said midpoint theorem, now we're saying Converse midpoint theorem. Okay, guys, then I want you to copy that down. That is Converse midpoint theorem, the converse of the midpoint theorem. And then you can just also draw that diagram. Please. Remember we discussed yesterday what it means when you have the converse of the theorem. Basically, they are taking the original theorem and just kind of reversing the conditions. Okay, so we are going to talk through this now. We'll just quickly copy it down. That's a flowers now. I got to have good news. They're not going to have to prove this one, right? Just do the one proof, which is midpoint theorem. But you do need to be able to use this, right, in calculating. We're actually going to do questions today where we're doing calculations. All right, so then we need to be able to identify when we must use the midpoint theorem and when we must use the converse. They're going to have different reasons as well. All right, so it is quite important. All right, what does midpoint theorem say again? If you have a line going from the midpoint of this side to the midpoint of that side, then it is parallel to the third side, right? Converse midpoint theorem says if you have a line going from the midpoint of one side, so we can see from this picture, do we all agree that D is the midpoint of AB? Right? Because it's showing here that AD is equal to BD. So we have a line going from the midpoint of one side, but then it's also parallel to another side, the second side, let me say. Then this line is actually going to the midpoint of the third side as well. Okay, so if you have the midpoint of one side and parallel, then it's going to the midpoint of the other side. What if it was just given that DE is parallel to BC? What if they didn't tell us that D was the midpoint of that side? Could we still say that it was going to the midpoint of the other side? Okay, what if I have a line going here? Let me show you. What if I have that? Right, so this line is parallel to BC, but is it going through the midpoint necessarily? Right, no. So guys, that is why it might, but we can't say for sure that it would. That is why you have to have a line going from the midpoint of one side, parallel to that bottom side, then it will definitely go to the midpoint of the other side. Okay, so what I want you to do is in a different color, please, we are now going to fill in that to show that E is the midpoint of AC, we will show that those two parts are equal. We would be able to write down, so I'm going to write it next to this picture, that AE is equal to CE. Or we could also just say E is the midpoint. E is midpoint of AC. That's the conclusion that we can come to given the information that they've given us here. Guys, this reason is much more complicated, unfortunately, than just converse midpoint theorem. We're not allowed to write that down. We have to say line through midpoint parallel to second side. And when you're using midpoint theorem, your reason is just midpoint theorem. When you're using the converse, you have to write line through midpoint parallel to second side. Okay, are there any questions at this point, guys? We are going to practice using it now, so maybe you're not quite sure how we're going to use it yet, but I'll clear that up. Okay, I would like you to write example 1. I hope you will be able to read. Are we all done there, guys? Okay. Okay, just please write example 1. I'm actually going to just up the brightness on this. Okay. Is that big enough? Can you guys read that? All right, just let me know if you can't read something there, and I'll just read it out to you. So that's example 1, please. The figure below shows a large triangle with vertices A, B, and D. And a smaller triangle with vertices at C, D, and D. So they're basically talking about this larger triangle, and then they have the smaller triangle here. All right? Point C is the midpoint of BD, and point E is the midpoint of AD. So they're giving us some information there, which will fall into account. And then, guys, if you're drawing this picture, you don't have to write this section here where they're saying 3 angles are given, blah, 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 you can just read it all. But the question is, they want us to find the value of DCE, that angle. Yes. Yeah. So that's what we're all going to do now. So now we can't read those angles that are in the triangle, they are also written underneath, so you can't read it off of the diagram in the sentence just below the triangle. Exactly, only do that in the office. So we think that you are able to do this question on your own, you can get going on it. Yeah, wait. We'll just wait for everyone. Okay, what you say? I have a toddler with a stomach bug, you can have a drive for me.
What can we say?
You're going to use the footnotes.
It can say, firstly. And
You don't actually even have to say that out. You don't have to even write that out. All right, guys, do we notice that X-shaped thing? Hello, can you go? All right, we have an X-shaped there, right? So if, remember, this is very important. If you have parallel lines, so if CE is parallel to AB, then angle DCE is going to be equal to 91. Is it given that these two are parallel though? No. What is given, guys? This bit of information here, which is written down but not drawn onto the picture, is the key to the whole question. Point C is the midpoint of BD. So that means that these two bits are equal. And point E is the midpoint of AD. Right, so there we have AD. That means that these two bits are equal as well. So do I have that CE is a line joining the midpoints of two sides? Yes. Meaning that CE is in fact going to be parallel to AD. My reason for that is going to be midpoint theorem. All right. So we're going to say CE is parallel to AB in brackets midpoint theorem. You do not have to first state CD equals BC and DE equals AE. That was given, right? By them telling us this, by them giving us this last sentence here, they've already stated that actually. All right, so all you need to write is that CE is parallel to AB, midpoint theorem, and now we can use that X shape, right? Corresponding angles. So therefore, DCE is going to be equal to 91 degrees. Corresponding angles. And now you have to just list your parallel lines. But I'd be very strict in marking a question like this. If you leave out that line, you're going to get 0. Because then they're going to say, oh, you are making an assumption that these two lines are parallel, 0. All right, they're not going to say you're losing 1 mark for leaving out a step. Okay, if your wording doesn't follow a logical sense, unfortunately, you're going to get 0. Even at the finals, they're very strict on if you assume anything based on the diagram. So if it just looks like they're parallel and you just say, oh, they are, I can use that, you're going to get 0. Thanks for you. Any questions on that one? Right, example 2. Again, if you are able to do this question, you can go. All right, guys, they have given us a triangle again. They're saying that line ST, which is that middle line there, bisects PQ at S. What does that mean? This line bisects PQ at S. That means that S is the midpoint of PQ. Yeah, that language doesn't mean the bisect. Remember that bisect means cutting in half. Right? And then we're saying that line S bisects PR at T. So T is also the midpoint of that side. So again, I can use midpoint theorem, right? Now in this case, do I even need to state that those two lines are parallel? Does that have any influence on what I'm trying to find? It's saying ST is 7 units. Determine the length of QR. So I want the length of the side. Now remember that midpoint theorem has two conclusions, right? The one is, yes, ST is parallel to QR, but also ST is half the length of QR. That's the second part of the midpoint theorem. So if ST is 7, what is QR going to have to be? 14, right? So you can literally just write QR is equal to 14 units. Midpoint theorem. Nope. You can't say that they're parallel, but we don't need to use it in this case. Okay, so at this point, I think this work seems a bit silly, but don't you mind? It's ramping up now. All right, exercise 3 or example 3 rather is going to be a little bit more interesting than the ones that we've done so far, and this is also the last one. Sorry, I know you guys have been doing a lot of writing in this lesson. That is example 3. That point there at the end is an I, in case you guys can't see that, but at the bottom of this right corner of the triangle there is point I. Oh, sorry, I'm seeing now they didn't put suffix on here. Oh dear. It's on those angles, guys. They didn't put suffix over the J and the H there. This is a man, you can just add it in. So yes, but you can't write that as your reason. You're gonna have to write this down. Yeah.
No, but you don't know.
Corresponding angles.
Oh, so you don't have to do something. Parallel.
Yes, you are. That's gonna be your
Corresponding.
corresponding angles are any angles in an X-ray, but they're
Yeah.
only equal if they lie between parallel lines. So even if that bottom line was like skewed, you could still call them corresponding angles. They just wouldn't be.
These are.
Yes. So they put this, yeah.
After that, define that. Okay. Point.
No? Mhm. All right, guys, let's take a look at what's going on here. So in the diagram, GJ is given as 1.5 centimeters. Then they've given that GK and KI are both 2.5. So that means that K is the midpoint, right? K is the midpoint of GI. We can see that there. They didn't tell us what JH is. Obviously, we're going to have to find that. So guys, we can't use midpoint theorem in this case yet. All right, because if we want to use midpoint theorem, we need to have midpoint to midpoint. Okay, at the moment, we just have one midpoint. They're asking us, oh, sorry, they're also telling us that these two angles are 90-degree angles, both of them. We can see that on the picture. They want us to determine the values of X and Y. All right, now guys, if we had, I mean, these are obviously a right angle triangle, so we could use pi tag, all right, if we had enough information. We don't in this case. What I want us to just recognize here is that these angles are equal to each other. That's a 90-degree angle, that is a 90-degree angle. Can you see that F shape thing? So those are corresponding angles that are equal, guys, and corresponding angles are only equal if they lie on parallel lines. Okay, so we can say that these two lines are equal. JK is not equal to parallel. JK is parallel to HI. So I'm going to write that there. JK is parallel to HI. Your reason is going to be corresponding angles equal. You can also use the equal symbol if you want. No. The reason I'm going to deduct them off if there's no point.
Yeah. This will make people so strict.
All right, JK parallel to HI. Guys, what you cannot do is say corresponding angles JK parallel HI. All right. That reason, when you say corresponding angles and the parallel lines, that's what you use when the parallel lines are given, or when it's given that they're parallel. If you are proving that two lines are parallel, you have to say corresponding angles equal, or alt angles equal, whatever. All right, if you have a big shape. So that's very important. Maybe you just want to highlight that equal there. If you don't have the word equal, or at least the equal symbol, you're not going to get that mark. Okay, you also can't just say corresponding angles. You have to say corresponding angles equal. Okay, so let's fill that in on the picture. How does that help me now? What does that mean?
We know that the lines are parallel, and that's the line that this one of the. So, that's we have all the.
Converse midpoint. Yes, thank you. Guys, remember Converse midpoint theorem says if you have a line going from the midpoint of one side of the triangle, that's also parallel to the second side, then that line goes to the midpoint of the third side. Okay, so that means that J is the midpoint of GH. So we can use that to say that X is going to be 1.5 centimeters. If J is the midpoint, then these two parts are supposed to be equal to each other. Now we need to write that long reason, right? Line through midpoint parallel to different side. Okay, so we found X. Now we need to still find Y. which is this side over here. So what can I do now, guys? There are multiple options, yes. I can use pi tag, right? I have that is 2.5 and 2.5, so this side is 5. What about this side? 1.5 and 1.5, this is 3. So what is y going to be? Do we know that pi tag triple? 3, 5, and 4, okay? Or you can just use pi tag. So this length is 3. That length there is 5. So you can use Pythagoras. Oh, that's very skewed. Sorry. So you can use Pythagoras in this big right angle triangle to get y. So you're going to say 5 squared minus 3 squared. That is 16. And then the square root of that is y. Is 4. All right. I'll write that down now. Or what I actually think what they did in the textbook, which would have been a longer method, but you also could have done it, is they calculated this side using Pythag, right? The 2.5 and the 1.5, they found that this was 2. And then they said now using midpoint theorem, if that is 2, then that one has to be 4. All right, but that would be a longer method. So let's write down the shorter one where we're using Pythag. So I'm going to say y squared is equal to 5 squared minus 3 squared. Remember, you have to write down Pythagoras. Or if you just know that it's going to be 4, you can write Pythagoras triple. That's also fine. So this is 16. So y is then 4 centimeters. That middle line is not necessary. You can just go straight from that to y is 4. Any questions, guys? All right, I'm going to give you a few to just practice on your own. You don't have to redraw the diagrams when you are just doing these. Don't worry. Exercise 9.7 on page 220 in the textbook. And I want you to do 1, 2, and 3. Okay, you can get going on that.